Good day to everyone. Today, we will discuss to you our study using ProModel as simulation tools for utilizing the construction operations modeling. On my part, I will discuss to you the objective of our study and related review literatures. Objective of the study: to improve the operational structure in construction sectors. The research objective is to create a simulation model using ProModel as simulation tools. To understand how different works environment and resources limitation affects our workflows through model simulation. The model can be used to examine the effects and different resources based on the construction options on building time, cost, and resources use. Also, to assist the construction personnel in evaluating, analyzing, and making decisions about the current conditions by using the ProModel research. Background of the study or literature review. These slides highlight the recent research on operation management and construction, as well as the usage of ProModel application in our construction operations integrated simulation framework. The usage of computer simulation in the building industry is also covered. First off, modeling simulation limitation and the use of inaccurate data limit the relevance to the field of construction management. Despite the fact that better tools may now be paired with computer simulation approaches to examine the building projects. Nonetheless, there are still few instances of ProModel being used in the construction management, despite the obvious benefits of its application in the industry. This is true even though the building industry has advanced in many ways, from management strategy to technology developments. Simulation. Simulating a process or system entails reenacting how the actual system reacts to ongoing events. Designers and engineers utilize simulation modeling to better understand whether, how, and under what circumstances as a part could break, as well as what stresses it can withstand. With the contribution of Harris and Kahn, who systemized the initial simulation techniques that were applied in several circumstances. The study of simulation as a field of knowledge began in 1948 by Asprey, 1990. Some of the well-known simulations as a result of the development of computer technologies includes the Monte Carlo methods and the application of statistical and physical mathematical model by cost. In 1997, Halpin pioneered the use of simulation and creative process by introducing Cyclone, a simulation tools created to study and analyze and regulate the processes in the operation of repeating characters. This is by Halpin in 1992. A more user-friendly, straightforward manner to describe simulation and processes was made possible in 2000 by 3D visualization technologies, as stated by Kamat and Martinez in 2008 study. Eventually, when more specialized software entered the building industry, it became possible to come even closer to actual system. On the other hand, using 4D models created by combining the 3D models with construction schedule has made it possible to see the status of the project in real time. Now, using the ProModel, It is an object-based modeling system with an easy-to-use graphical user's interface and tools for object-oriented modeling. For discrete simulation, which stimulates changes in chains state across discrete time, both methods do away with the needs of programming. According to Martinez and Pochios in 1991, taxonomy of simulation approaches, ProModel is a process interaction, PI-based simulation methodology. Other paper instances use ProModel to examine the amount of client of waiting line lost during the bank services operation.
On my part, I'm going to discuss methodology. Let us look at the components and model analysis. The actual building process for concrete pouring scenario was examined following the actual concrete pouring of 200 cubic meter, which is necessary to pour into the slab and beam utilizing a bucket and tower crane over one working day period to develop the simulation under pro-model environment. The researchers considered a local concrete ready-mix The researchers considered a local concrete ready-mix supplier who has met the following qualifications: it has the ability to supply large volumes of concrete, sufficient fleet of concrete transit mixers, batching plant location is within an acceptable travel distance, the quality of service, professional profile, has a reserved batching plant in case of plant breakdown. The following components are considered: location. These are the places where entities are processed or held. Locations are used to model elements like test station, recycle center, unload bay, parking area, and the working process. There are 7 locations implemented on this study. Entities, which contains the concrete batch, unit concrete, and concrete waste, which are tracked as it moves through the system model. Arrivals. These are the accesses of system entities, where the amount of each entity is one truck arriving at each location. Events, which includes the arrival of concrete, work in progress, and finishing. Activities. This includes the concrete testing once truck arrives at site, concrete truck waiting in line when tower crane is busy loading concrete from another truck. It also includes concrete unloading, concrete transfer by bucket aided by tower crane, concrete pouring, vibrating of poured concrete, and leveling of poured concrete. Next is processing. It describes the entities transmitting within the system and the procedures that take place for each entity at every location. Note that the first truck arriving at site is processed initially. Resources. It consists of tower crane, waste handling laborer, one general laborer deployed at ground floor level, 3 general laborers deployed at the concrete pouring location in upper floor, one mason, and 2 level of labor. Figure 1 shows the complete process flow of concrete pouring activity which has been considered on this study. It shows the complete process from concrete arrival up to the finishing activity. Data collection. Let us discuss data collection. Researchers gathered the normal approach or procedure of concrete pouring in Qatar to develop the basis model. Researchers ensured that the simulated concrete pouring process and activities adhered to local and international standards, such as ensuring that the concrete is tested by an approved third-party laboratory and that the allowable time duration between transportation of concrete and placement of concrete was considered. The researchers discussed all of the information gathered during this simulation and appraised the outcome, rate of concrete pouring, and bottleneck of the operation. To estimate the deterioration probabilities of concrete, to determine the concrete pouring rate, and to determine the possible outcome of the simulation, the concrete properties, transport time from batching plant to site, time consumed during concrete testing, time consumed during queue at site, and discharge time will be required. The number of trucks in the system's queue, as well as the processing time from truck arrival to concrete leveling off, are all possible outcomes. Furthermore, some choice variables that could be studied in the future include labor allocation, worker competency, hot weather concreting, and the amount of accessible equipment.
On my part, I will be discussing results and discussion. Modeling elements of Pro Model. The modeling elements in Pro Model, as listed in Table 1, provide a set of contracts for representing the physical and logical components of the system being modeled, and physical elements of the system such as parts, machines, or resources can be referenced either graphically or by name. A Pro model contains main elements such as entities, locations, resources, and path networks, and interactions such as arrivals and processings. It also have additional elements such as variables and attributes, which we'll be discussing to our Pro model simulation on the succeeding slide. Case study: a concrete pouring and waste handling simulation model with Pro model. The case study is part of concrete building construction located in the Lusail Boulevard project from the city of Lusail, Qatar. 200 cubic meter concrete was required to pour into the slab and beam steel formwork using a bucket and a tower crane over one working day period. 28 truckloads of ready-mix concrete, each 8 cubic meter, were delivered from an off-site concrete plant to the site. It took about 26 minutes to unload one truckload of concrete, which could fill up about 5 bucket loads. The tower crane swung up a full bucket of 1.5 cubic meter, poured concrete into the working area, and then swung down the empty bucket to the truck unloading area. Laborers then vibrate concrete and level off the surface of the pour section. A total of 136 pour sections were placed on that day. In addition, 0.15 cubic meter of each truckload of concrete was unloaded by a worker for slam test at the quality control testing station. The concrete waste from testing was collected and transported by the worker to the recycling center on site for making concrete blocks. The resultant Pro model is shown in Figure 2, which with the interrelationship between location defined in the processing. The transit times of resources were defined in the separate spreadsheet called path network, as shown in Table 2, and details of the model development are given in Table 3. In Table 3, the entities concrete batch and concrete waste represent a truckload of concrete and a unit of concrete waste from testing respectively. The location unload bay was a counter for recording the number of unit concrete delivered. The value was automatically deducted by 1 as one of the units was transported to the location for processing. The variable work in progress WIP increased by 1 once the unit concrete was in processing. When the unit concrete was consumed and one of the sections finished, the variable WIP decreased by 1 and the variable finished section increased by 1. The waiting duration weight T 4, 5, 6 of the entity concrete waste was the sum of the time spent on the test T 2.5, 3, 3.5 and the waste collection T 1.5, 2, 2.5. The transit and return times of the resources were identical and all the travel time between location was set in bidirectional mode. The location unload bay was needed in Pro model, acting as a buffer location so as to avoid disruption on the concrete unloading activity. The Pro model were executed for 10 Monte Carlo duplication. The simulation started at time 0 and the time units in the model definition were on minute basis. The results indicated the average pore duration of 540 minutes. Animations on model further revealed the valid patterns of resources movement and the correct sequence of activities, all conforming to the actual observations.
In conclusion, the construction sector is constantly looking for better ways to manage construction projects and enhance productivity. Delays in construction projects are common and can occur for a variety of causes, which can have a significant financial impact on the project. To avoid project length delays and improve the operational structure, a model for discrete event simulation of the tasks and materials needed to generate cast in situ concrete casting in Qatar construction projects is proposed in this study using Pro model. The model simulates the effects of various work environments and resource constraints on workflow. This study is a component of the Lusail Boulevard project in the city of Lusail, Qatar, which involves the construction of concrete buildings. The case study presented in this report demonstrated the use of Pro model in simulating a model for concreting and waste handling process. The model provided a detailed representation of the system being simulated, including the arrival of concrete batches, the processing of concrete, the collection and transport of concrete waste, and the transit times of resources. These simulation results generated by the Pro model accurately reflected the real-world scenario and provided valuable insights into the performance of the system. The model revealed the average pore duration of 540 minutes, the valid pattern of resource movement, and the correct sequence of activities. The use of Pro model in this case study demonstrates the effectiveness of simulation modeling in analyzing complex systems and optimizing their performance. The development of simulation models will allow construction companies to monitor and reduce project completion delay. With its comprehensive set of modeling elements and user-friendly interface, Pro model is an excellent choice for organizations seeking to optimize their system and processes. And that is the end of our report. Thank you for listening and have a good day.